Welcome back, nerds. We are going to continue solving, actually not even solving polynomials, factoring polynomials, and then we'll get into solving polynomials using factoring today, which isn't even a new concept because you've solved quadratics by factoring, and technically a quadratic is a polynomial. So no new knowledge today, just incorporating yesterday's skills into, oddly enough, yesterday's skills. Yesterday, you didn't see any special cases fall out of special cases. You didn't see any special cases fall out of grouping. You're going to see both of those things today. Always on the hunt. Always on the lookout. Speaking of on the hunt and on the lookout, something you're always going to look for first when factoring is GCF. That's always your very first step. Look for GCF, and I don't see one. So there's no GCF here, okay? Nothing that you can take. Other than 1, and 1's always a GCF. That means we're going to factor by grouping because I have 4 terms, and that's your only option right now when you have 4 terms is to factor by grouping, and good golly, hope it works. Artificially group, first 2 terms, last 2 terms, make sure that you capture that symbol in the middle into the second group. And then we just look for GCFs of stuff. So looking for the GCF of the first red group. What would it be? X squared. Good. So we get x squared in the first red group. And if we factor out that x squared, which is a form of division, we're going to get x minus 3. Now in the second group, the numbers 2x and negative 3, they have absolutely nothing in common. Except for 2x minus 3? Yeah. What is the only thing that these 2 things have in common? 1. Just a minute ago I said 1 is always a GCF and usually it doesn't matter. Well, when you're grouping, it'll probably be one of the only times where you actually care if the GCF is 1. Because you need to be able to pull a GCF from both of these groups. And sometimes it is just a 1. This is one of those times. And obviously dividing by 1 doesn't change anything, so I will still have 2x minus 3 in that red group. Your 2 groups both have a 2x minus 3, which means I can factor out a 2x minus 3 as a GCF. I will undistribute that thing from both of my red objects. My red objects will leave behind an x squared and plus a 1. So I'm looking for, however many of you are in this room, like 30, I think there's almost 30 of you. I'm looking for like 30 voices to just say yes or no. Class, am I finished? Everybody said no. I am finished. And here's why. This is not a special case. X squared plus 1 is a squared plus b squared. And a squared plus b squared does not factor. So this is finished. Do not fall into the trap. X squared plus 1 can't factor. It has only imaginary solutions. It never encounters the x-axis because it's just a quadratic that's been shifted up 1 points up. It doesn't factor. X squared plus 1. A squared plus b squared. Don't try. Okay? Okay. In part B, there is a GCF. Part B begins with a negative number. Anytime you're factoring something that begins with a negative number, your GCF is negative. Even if that GCF is just negative 1. If you have a negative leading term in your factoring, I need you to pull a negative GCF. It's not just negative 1. What else could I divide all of these by? Negative 2. 4 does not go into 54, it goes into 52, and it goes into 56. But 2 goes into all of them. So I can divide out a negative 2 as a GCF. And let's see what we get. Positive 8x to the fourth, negative 8x to the third, negative 27x, and positive 27. So the polynomial in black has 4 terms. You only have one way of factoring that right now, grouping. Make sure you capture the middle symbol in the second group. Very common student mistake, like I said yesterday, is losing the GCF. So that negative 2 is going to be the very first thing I write on the next line to make sure that I don't lose it. What is my first green GCF? 8x to the third. Someone in the back said it. 8x to the third. If I divide both of these by 8x to the third, I get x minus 1. Please never say minus 0. That doesn't make any sense. You can never get 0 as an answer when you're dividing unless you started with a 0. Anything divided by itself is always going to be 1. Now we're looking at this green group. What is its GCF? Negative 27. See, remember, because I'm factoring something that begins with a negative, my GCF is negative. So negative 27. Leaving behind the x and the minus 1. I don't want to accidentally lose my GCF of negative 2, so I will make it the very first thing I write. Lots of colors. The x minus 1 exists in 2 places, which means I could undistribute it from those 2 places. And it'll leave behind my 2 green GCFs. This one is not finished because this is perfect cube minus perfect cubed. This is a cubed minus b cubed like we practiced yesterday. 8 is a perfect cube, x to the third obviously is a perfect cube. 27 is a perfect cube. I never try to factor the sum or difference of cubes without the formula. I always write the formula, even when I'm doing it on my own. When there's nobody looking, I always show the formula for myself because I can't keep it all in my head. There's just too many bits. We need to figure out what A is, and we need to figure out what B is. So A is going to be the cube root of a to the third. So A is going to be the cube root of this right here. Cube root of 8x to the third is, please shout it out, 2x. Good. And B would be the cube root of b to the third, or the cube root of 27. So B is 3. Okay, before I finish up this question, someone in first period asked an amazing question, and I'm shocked it didn't come up yesterday. But they asked, what happens if A or B is negative? The answer is, it can't be. Neither A nor B will ever be negative when you're doing this process. That's why we have 2 different formulas. One is for when this is a plus, and one is for when this is a minus. So your A and your B will never care what that symbol is. A and B will always be positive. But Mr. M, what if the front thing was negative? Wouldn't A be negative? No, because if the front thing is negative, you should have pulled a negative GCF, even if it was just negative 1. Your A and your B should always be positive. And if one of them is negative, something's not right. Stop working, go back and look at it again, okay? Anyway, I believe it was Emberly. I think that's who asked. Great question. I'm glad she asked. We grab blue. Okay, We got the negative 2, we got the x minus 1. We don't want to lose those. Wish I'd had just a little bit more vertical space. So I'm going to squeeze another line right here. And now I'm going to fill out my purple formula with this a and this b. We've got a minus b. I've got a quantity squared, ab, and then b squared. Cool. Two x quantity squared, you have to square the 2 and the x, or you can say it's 2x times 2x. Either way, you're going to get 4x squared. 2x times 3 is 6x, and 3 squared is 9. And recall from yesterday, please, anytime this is an x squared quadratic, it will not factor, so you don't have to worry about it. But what if I was asking you to solve? I asked it yesterday, I'm going to ask it again. How do we solve quadratics that don't factor? Quadratic formula. Good. If you were to use a quadratic formula on this, you would get complex solutions. They would have I in them. And it happens. Just making sure that we keep reiterating. But this is factored. 100% finished. So now you've seen a special case come out of the grouping. Would you like to ask me any questions in regards to special cases and grouping? No? Okay. Then on to example C. We have a GCF. What is it? Negative 3x. One person said it. I'm hoping everybody in the room knows that the GCF is negative 3x. If you're not sure how to pull GCFs, please say something to me. But negative 3x is it. Dividing everything by negative 3x is going to get me x to the 5th minus 4x to the 3rd plus x squared minus 4. And just like the last one, we're down to 4 terms. We're going to have to go ahead and factor by grouping again. It's getting kind of tedious, all this factoring by grouping, isn't it? You know the good thing about tedious? That means you've done it so much that it should be easy come test time. But let's group this bad boy. Make sure that you capture that middle symbol in the second group. And looking at your first green group, hold on. I'm going to start by writing my GCF. Looking at the first green group, what do they have in common here? X to the 3rd, x cubed. Leaving behind x squared minus 4. The next green group, what's the only thing that these two terms have in common? Positive 1. Once again, we have a time where we have to say the GCF is simply a 1. And that happens. It happens. When you're grouping, it's going to happen often. The negative 3x, don't lose it, goes on the front. The two green things both have an x squared minus 4. That means I can factor off an x squared minus 4 from both of my green objects. And when I do, the green objects that are left behind will be x to the 3rd plus 1. And for the very first time ever, you have a grouping question that has 2 special cases. This is a squared minus b squared. This is a cubed plus b cubed. This one's big. 2 special cases inside the grouping, and there was a GCF. It's got all the stuff. All the stuff. Okay, I got to figure out a good color combination. You know what? Maybe I'll just do green and black for these. So we've got the a squared minus b squared. That formula is going to be a plus b times a minus b. We might as well identify what our a and b are. So black a is going to be the square root of x squared, or just x. Black b be the square root of 4, just 2. The green one is the sum of 2 cubes, a cubed plus b cubed. I'm going to try not to encroach too far over here. Get skinny, math. Think thin thoughts. Encroached a little. Did what I could. If a cubed is x cubed, then obviously a is just going to be x because it's the cube root of that. And if b cubed is 1, then b is just 1 because that's the cube root of 1. And if you're okay with it, to save some space, I'm not going to show me plugging in the x and the 1 using parentheses. And the reason why is because neither my a nor my b is 2 objects. So this is literally going to be x squared minus x times 1 plus 1 squared. I don't think I need to show that work. Final result, our negative 3x from the front. Our black x squared minus 4 factoring into x plus 2, x minus 2. And our green factoring into x plus 1, x squared minus x times 1 plus 1 squared. Look at that. It had all the stuff. This plus sign is special. There we go. That's a big one. Had a lot going on. And again, I ask, any questions on it? Anything I can help you with? Or is it really you're seeing it as the same old stuff, just older skills stuck inside of grouping? Again, the hardest part is, do you know the formulas for the sum and difference of cubes? I hope. I hope that's the hardest part. Because that's just memory. And you're all pretty good at memorizing things. I've seen the TikTok dances. You should be able to memorize some formulas. Okay, part D has a GCF. What is that GCF? You guys can just shout it out. It's 3. The GCF is 3, yeah. It's going to get me x to the 4th minus 81. And because this exponent is even, x to the 4th is technically a perfect square. And we could see that 81 is a perfect square, and there's a minus sign. So in here, this black stuff is an a squared minus b squared situation. So this a and this a, you know they're going to multiply to get me my a squared, you know, if you were to go ahead and do the distribution, the FOIL method. So the front of these parentheses and these parentheses have to multiply to get me to x to the 4th. So what does that front thing have to be? What is a? X squared. So you're all cool with the fact that if you want to multiply two objects that are the exact same thing to get an x to the 4th, that they're both x squared, right? Okay, good. Because I'm going to be talking about that in just a moment. And b is just going to be the square root of 81. B is 9. We've got our red 3. And my x to the 4th minus 81 will become x squared plus 9 and x squared minus 9. And I will tell you, I'm not finished. We got a special case going on. But I'd like for all of you to shout out a number. The answer is either 1 or 2. How many special cases do we see here? 1 or 2, class? Mixed bag, but most people said 1. There is only 1. This is our special case. Because a squared plus b squared does not factor. So this is stuck. X squared plus 9. Can't do anything with it. But this one I can break apart. Where a is, the square root of x squared, and b is the square root of 9. And that will finish it up. We've got our 3 on the front. We've got this x squared plus 9 we can't do anything with. Then we've got an a plus b, which is x plus 3, a minus b, which is x minus 3. That one is finished. And we know we're finished because we're down to first degree stuff and something that doesn't factor. That's how we know we're finished. So that one was a special case inside a special case. That's the first time you've seen that happen. Special case hiding inside a special case. All right. Remember a little bit ago, I was saying, hey, you're all comfortable with the fact that these two things have to match and they have to multiply to an x to the fourth. So everybody was comfortable saying they were both x squareds, right? Okay. Examples E and F are very special quadratics. Yes, they are quadratics. And the way we recognize them as quadratics, especially the kind we can factor, is the middle exponent is half of the front exponent. When that happens, more than likely you have a factorable quadratic on your hands. I'm trying to figure out what color I want to use. Pretend for a moment it had said, and I'm just going to put in quotes. I'm going to put in quotes. Like, pretend you saw this. Would you be able to factor that easily enough? You'd be looking for the two numbers that multiply to negative 12 and add to negative 1, right? What two numbers multiply to negative 12 and add to negative 1? Negative 4 and positive 3. Now, if it had been this thing that's written in red, we would have had an x here and an x here. Because this x times this x would have given me this x squared. But I actually need these two front things to multiply to get me this x to the fourth. And that's why they're both x squared. How do you feel about that? I need to know if that's going to be okay for you to handle. That the reason why we were able to do that is because the middle exponent was exactly half of the front exponent. If the middle exponent had not been exactly half of the front exponent, we would not have been able to guarantee that these two front things were the same. One of them could have been x to the third, and the other one could have been x. But because the middle exponent is exactly half of the front exponent, it guarantees for us that there will not be any x to the thirds, and there will not be any x's. There will only be x to the fourths and x squareds. Okay? And this is not finished because that is a special case. Where a squared is x squared, so a is just x, and b squared is 4, So b is just 2. Our final factored result will be x plus 2, x minus 2. Oh, and then this x squared plus 3 that I can't do anything with. Because not only does it say x squared plus, but 3 isn't even a perfect square. I mean, there's just like nothing going on there at all. So we have x plus 2, x minus 2, and then this x squared plus 3. Fully factored. You all right with that? Then we'll go to example F, where you will see a very similar situation unfold, where the middle exponent is exactly half of the front exponent. That guarantees to me, when I factor, that these two parentheses will begin with the same thing. So what's going to be in the front of both these parentheses? The two things that will multiply together to give me an x to the 6th. X cubed, x to the 3rd. The dead giveaway is, it's the thing in the middle. See, x squared, x squared, x squared, x to the 3rd, x to the 3rd, x to the 3rd. Okay. Now, the two numbers that multiply to 16 that add to 10, you guys could just say them. 8 and 2. Perfect cube plus perfect cube. That's a special case. Show of hands, how many of you have accidentally memorized the formulas because you've written them every single time? Show of hands. Only 3 people? Really? She says yes, as in yes, you memorized it, or you're not one of the ones that memorized it? You still haven't memorized them yet? Got to write it 2 more times. Okay. So haven't started the homework yet then. I'm just having fun with you. Alrighty. Let's see. If a cubed is x cubed, then a is x, and b cubed is 8. B is the cube root of 8. Do a. 2. And we're ready to go. Oh, wrong color. Green. There it is. We're going to do this a plus this b, so x plus 2. Then, because neither this nor this has 2 parts, I don't need to show the whole wrap it in parentheses and square it. I can literally just say my a, which is x squared, minus x times 2, plus 2 squared. Oh, and the x to the 3rd plus 2, it's still hanging on. It doesn't factor, because 2 is not a perfect cube. We're not finished, but are there any questions I can answer about factoring by grouping, factoring special cases, GCFs, special cases in special cases, special cases in groupings, special quadratics? Not a question in the world. Okay. Easy peasy then. Solving by factoring. You have solved by factoring this year already, and you solved by factoring in Algebra 1 as well. In order to solve a quadratic, let's just say it's a standard quadratic by factoring, it had to equal 0, right? Well, that's not any different. Technically, a quadratic, a parabola, is a polynomial. You can't solve any polynomial until it equals 0. So we say, polynomial must equal 0 to solve by factoring. So if it didn't equal 0, well, you would need to make it equal 0 by moving everything to one side. Now we can solve by factoring. So again, always on the lookout for GCFs. Nope, no GCF. Got 4 parts. Your only option's factoring by grouping. You know, orange hasn't gotten enough love today, so I'm going to use the orange pen to group. Just make sure you capture that middle symbol in the second grouping. What's my first orange GCF? 4x squared. Oop, I dropped my pen. If I divide a 4x squared out of both of these, it's going to leave me an x plus 3. What's the next orange GCF going to be? Negative 9. And if I divide out a negative 9, I will get an x plus 3. So I've got this x plus 3 in 2 different places. I can undistribute that x plus 3 from the 2 orange places, and it will leave behind the 4x squared and the minus 9. But we're not finished, because that is a special case. 4x squared is a perfect square, 9 is a perfect square, and there's a minus sign in between them. That is a squared minus b squared. So if a squared is 4x squared, then a is the square root of 4x squared. What's the square root of 4x squared? 2x, good. And b squared is 9, so what is b? 3. Less people were confident about that than they were about saying 2x. Strange. Fully factored x plus 3, which is this black term. Now my orange term is going to split into a plus b, 2x plus 3, a minus b, 2x minus 3. And it all equals 0. Now we could do something that you learned how to do in Algebra 1. When it's factored and it equals 0, then all you have to do is set the individual parts equal to 0 and get x by itself. So you could say, you know that x plus 3 equals 0 gets you a solution, 2x plus 3 equals 0 gets you a solution, and 2x minus 3 equals 0 gets you a third solution. That first one's going to get me x equals negative 3. This one tells me 2x equals negative 3. This one tells me 2x equals positive 3. And then for these two, I will need to divide by 2 to get x all by itself. And I will have all 3 of my solutions. Negative 3. Negative 3 halves, positive 3 halves. Solving a quadratic, solving a polynomial by factoring. Gavin, yes sir. So, you know what's funny is someone in first period asked the exact same question. Let me ask you, what Gavin asked was, do we have to make sure the answers work? Meaning, do we need to check for extraneous solutions? What is the domain of every polynomial? All real numbers, which guarantees to us that any answer we find is true. So you will never have to worry about extraneous solutions, which is nice, right? You're not trying to plug this crap in to this polynomial, right? That would be awful. No, luckily we don't have to, okay? Now, if the beginning question had fractional exponents, radicals, and we did some math to create a polynomial, then we'd have to check. But I'm never going to do that to you because that's just mean. We could. You have the skill set, and you already know how to do it, but it would just be mean. There's no reason to do that. So no, don't ever worry about it, okay? It's a good question. And this one is a lot like this one. Now it's not identical. This one says x to the fourth minus x squared minus 12. This one says x to the fourth plus x squared minus 12. So it's only a little different. It's only a little different. But I see that the middle exponent is exactly half of the front exponent, which means it factors instantly to two sets of parentheses. Of course, that's if it factors, obviously. But these two parentheses have the same thing in front of them. So these two objects need to multiply to get me x to the fourth. And since they have to match, it's x squared and x squared. I just need to know what two numbers multiply to negative 12 that add to positive 1. Four and negative 3. Do we have any special cases here? No, we don't. A squared plus b squared never factors, and 3 is not a perfect square. So this is factored. This is as factored as it gets with rational numbers. So that's it. But we're trying to solve for x. It's factored, it's set equal to 0, so we do the same thing we did in the last one. We set its pieces equal to 0, and we get x alone. So we have x squared equals, x squared plus 4 equals 0. And we have x squared minus 3 equals 0. So you start getting x by itself. This one will subtract 4 from both sides. This one will add 3 to both sides. So I have that x squared equals negative 4, and I have that x squared equals positive 3. How do I get x by itself? It is already squared. Square root both sides. We've done this a bunch of times this year, but what happens when you cancel a square with a square root? You can say it louder. You're going to have a plus or minus. Every time you cancel a square with a square root, you have a plus or a minus. You might have noticed right here that these two answers are exactly the same, but one is positive and one is negative. That's because I could have just added 9 divided by 4 and said x squared equals, in fact, I'm saying it, so I'm going to write it. This, if I had added 9 and then divided by 4, I would have had x squared equals 9 over 4. And when you take the square root of both sides, you would have gotten plus or minus the square root of 9 over the square root of 4. Plus or minus 3 over 2. So yeah, you're going to have a plus or minus for both of these. So what is the square root of negative 4? Let's see who remembers that old math from earlier in the year. 2i, there it is. So we have plus or minus 2i. And the square root of 3 is irrational, so you literally just say the square root of 3. Because that's as good as that answer is going to get. Do you have questions for me about that process? Why are you telling me to stop? This class period still has 9 more minutes in it. She's over here giving me the that's enough eyes. And do we have any questions about those processes? So you're comfortable remembering that the square root of a negative is imaginary. So you could find those. And if we had a quadratic in our factorization that didn't solve by factoring, how do we solve quadratics that don't factor again? Quadratic formula. Okay, so I'm just making sure that you know that as well in case that comes up. Because I'm going to call it there, nerds. Thank you. Yes.